Apart from the spear grass which is sweeping across the grasslands of Queen Elizabeth National Park up to the crater lakes in the north, the southern portions of the park have also been seriously colonized by a mixture of Lantana camara and Dicrostatus cinerea, which forms a cobweb of fence-like thickets that hinder animal movements and reducing grazing space for the animals. And in that way, this invasion reduces the carrying capacity of the park. Margaret Drichiru is a vet who doubles as a senior warden in charge of research and monitoring.
So it's a kind of interlocking, it's not a fence per se, but it's a kind of interlocking ecosystem, plant habitat system, where you find that the plants grow next to each other and then they just close up and then they form a canopy. And once this canopy is formed, most of the grasses below, they don't get enough sunshine to make their food, and so they thin out and they kind of disappear.
But more significantly, these invasive plant species are threatening other plant species that are important sources of food for the majority of animals here.
We feared that the changes in habitat were going to affect our populations of animals. The botanical name is Dicrostatus cinerea, and the local name is Cameranjojo, meaning that the elephant cannot manage. And so now the plant is taking over the park. Very, very large areas of the park have already been taken up. And what happens is it closes up and it has some form of thorns. And so you find that where the canopy has closed, then the grass becomes unavailable. And this affects the animal species that are grazing. And we haven't seen any other animal which eats it apart from elephants. But what the elephants do actually, they just pick the leaves. They don't really eat the whole plant as it is. And so once it closes up and has a thick canopy, and down here there's no grass, you don't have any grazers. They just have to leave. And so we are really concerned about that situation.
This situation now calls for systematic research to contain the negative trends posed by the sicko bush. They have instituted research blocks to find out which strategy works better. This research centers on 4 major trial blocks.
And now for us, what we have decided to do is we have set up this experiment place. It's one plot that we have set up here. The length is about 700 meters and the width is about 350. And so we have plotted it. The plot has now 4 blocks. One block, we want to leave it as a control. We want to leave it for a very long time, even if it is for tens of years, that's okay. We want to see how that plot changes. The only thing we have done around it is we have made fire lines and areas that are going to demarcate it and have it intact. And so maybe, you never know, after a long time it will grow into trees, maybe it will open up again, or maybe it will establish a totally new habitat. We don't know. So we want to see what happens. But then there's this block here. We have cut off the plant totally. We call it total thinning. Now when we cut it off, we definitely knew that it may regrow. Then one other treatments we started to apply is, because we don't want to keep coming back, there are areas where we have cut the stems, like those ones there, these ones here. You cut it to at this height, then you heap the shrubs on it. When they have dried, you burn it. And then we have people here who collect data on it to see whether that fire effect is going to kill the plant. But then there are small plots where we have also just cut and left it, like this one here, that one there, and it is growing. So we try to see which approach will be best for managing it. Then in this total eradication, we want to see if the grasses come up, if now the animal populations on it, on the plot, start to change. And we are definitely already seeing it. There's a lot of dung, animal dung, which never used to be there before. Then we have another block, which is the next block, where we are only removing 50% of that of the plant. We want to kind of create a situation where we have grassland and we have the plant itself to form a kind of woodland, wooded grassland. And then the hope is that in that mixed vegetation type, you're going to have mixed kind of animal species. You'll have the grazers, you'll have the browsers in it, and want to see how the animal populations come back up. Then we have another plot, another block following the 50%, where we want to remove just 25% there. So we are trying to see which percentage is going to create the most appropriate habitat for mixed feeders, you know. So that is what is being done here.
The cut and burn policy looks good. On the ground, this policy seems to be working, but feared to be tough and labor intensive.
So what they are doing here is they are trying to burn the stump which they cut inside there. So the reason why this burning is done on the stump is that when you cut these trees, they are so difficult to cut. And we have known that it takes a lot more time to cut them down to the root and then uproot it so that they don't regrow. So now a method we are using is you cut it at this height and then you pile the shrub on top of the stump, and then you burn the stump. When the stump is burned, we want to see if that method will be effective for controlling the regrowth. That is what is happening here. Where the burning has happened, in this ash, the level of potassium is high. And so the grasses that got suffocated by these plants as they existed now start to come out very, very well. This is the stump which they cut. So one of the approaches is they cut it up there, they heap the shrubs on the stem as it was still standing, and they burn it. But these saplings will come up. They are coming up on the roots which were left here. And so the principle is that when they come up, they start to grow, they are using the food which is in the stem which is down there. Once the food is finished, they should die. That is the principle. But as they keep growing, animals are also going to come and keep eating it. So you can see this is herbivory. There are some animals that have picked on the young shoots. This tip here is eaten. That is eaten. This is eaten.
This practical research is beginning to yield results, at least for some time. In the thinned plots, the pasture grass cover seems to be coming back, with the number of animal species and their population increasing.
Where they have done the 50%, the elephants are actually visiting much more than where nothing else is happening. And so it definitely blocks animal movement. But on the other side, if there's really no food for the grazers, there's no reason why they should come. The grasses are now very happy. You can see the grass cover has increased.
Alternative approaches are also being considered. John Makombo is the Director of Conservation at the Uganda Wildlife Authority, based in Kampala. Makombo feels converting some trees to charcoal could supplement the existing efforts on the ground.
We have a partner who we are going to work with to utilize the invasives, and he's in the preliminary stages to ensure that he gets the NEMA approvals so that we can have a kind of a factory that's going to utilize this biomass and produce like energy charcoal, some charcoal out of it, what we call bridges. Once this is approved by NEMA, then we should be able to move ahead with this.
It will now all depend on the strategies the researchers deem appropriate. A combination of positive research findings and concerted efforts should be deployed if the trains of nature in the Queen Elizabeth National Park have to move in the right direction.